Hello everybody and welcome to Fatal Fact. Today we are diving deep into the world of SSL traffic interception in Flutter Android applications. Flutter handles SSL TLS differently from your typical Android application, and in this video we are going to explore the inner workings. By the end of this tutorial you will not only be able to extract the functions responsible for SSL certificate verification, but you will also gain the skills to bypass SSL pinning and unlock the secrets of intercepting HTTPS traffic in plain text. So stay tuned because we are about to uncover some serious Flutter app magic. For this video, we are going to make use of a sample application which I have developed using latest Flutter SDK, and I have already uploaded the APK on our GitHub repository page, link to which is already mentioned in the description box. So if you want to follow along with this video, feel free to download the APK and install it on your device using adb install command. So let's have a quick look at how the application looks like. So here it is on my device, SSL pinning. And when we launch it for the first time, it will make a HTTPS request from the web server to retrieve latest news and display it in the UI in the form of list. Okay, so our aim here is to intercept this HTTPS request and see its request and response payload. Now, in order to intercept the traffic, we need to be present in the middle of the user and the web server so that we will be able to intercept the traffic, right? So to give you some idea how this looks like visually, let's say this user is our Android application. This is the web server to which the application communicates to retrieve this list of news. And here we are in the middle with our attacker machine, right? So what we will do now is we will redirect the traffic or the request which user is making from his or her Android application to our machine. And from here, after intercepting, we will forward the request back to the web server where it was initially requested for, right? So for intercepting the traffic, we are going to use Burp suite, which is already installed on my machine. Temporary project, click next, use burp defaults, and then start burp. It will create a temporary project for us. Okay, here under event logs we can see that proxy service has started already on localhost 8080, right? So by default burp starts listening from localhost on 8080 port, which we can obviously change by going into the proxy tab. Under options, under proxy listeners, we have the proxy settings, which we can edit by clicking on this edit button. And for now, let's keep bind port as 8080, and we need to change the bind address from loopback, which is localhost, to all interfaces. And before making the changes, there is one small change we need to do, which is under request handling. Here we need to make sure that this support invisible proxying feature is enabled. Now this is helpful when the client generates a non-proxy request rather than a proxy style request. So if I try to give you an example of how a proxy style request will look like, for get request, a proxy style request will have a host name, let's say apphost.com, followed by file name or the API name, right? But in case of a non-proxy style request, we only have the API name or the file name. So here we are missing the host name in the URL. And HTTP proxies needs to receive the full URL on the first line of the request in order to determine which destination host to forward the request to. In this case, Burpsuite will know that the request needs to be forwarded to this apphost.com. Okay. Normally, proxies do not look at the host header to determine the destination. So in such request, usually how the application identifies where the request should be forwarded is by looking into the host header. And by default, proxies do not look for the host header to determine the destination. So if the application is using non-proxy request, Burpsuite might not be able to capture it. So to make sure Burpsuite captures such request, we need to make sure that this feature is enabled. Okay, let's save the configurations, and that's it. Okay, so now our Burpsuite is configured. Next, we need to make sure that all the network requests made in our Android device will be redirected to the Burp suite, right? So for that, we need to configure proxy in our device, which we can do by going into the Wi-Fi settings, go to the settings, edit button, under advanced option, it's currently saying proxy is set to none. So we need to change it to manual, and now it's asking for proxy hostname and proxy port. So the proxy hostname is going to be the IP address of the machine where our burp suite is listening. We can get the IP address using if config command. So currently the IP address I'm getting is 192.168.1.18. So let's put it over here, 192.168.1.18. Then the proxy port, we have configured burp to listen at 8080 ports. So our proxy port is going to be 8080. Click save. And now the proxy is configured on our device. So let's do a quick rain check by opening up the web browser and trying to make a request. Let's say google.com. Hit enter. And now it's saying your connection is not private. Error certificate authority invalid. Okay. And if we go under HTTP history tab, we see that we do get some request, right? But not this one. So we can check the error logs in burp suite by going into the dashboard tab, and under event log we see that it's saying the client failed to negotiate a TLS connection to www.google.com. So why is it happening? It's because we are dealing with HTTPS request, and we need to make sure that the client, which in this case is our Android device, trusts the certificate of the server where it's trying to communicate. So normally when we request for google.com, it requests Google server, then Google server provides us with a CA certificate which should be trusted by our Android device by default. But now what happened is that we have redirected the traffic to our burp suite. So now the device is not communicating directly to google.com, but instead it's communicating with burp suite, and the burp suite CA certificate is not trusted in our Android device. So that's why we are getting this error. So to fix this, what we can do is we need to install or trust the CA certificate of burp, which we can easily do by going into http burp. This opens up this web page where at the top right corner we see this CA certificate. So if you click on it, CA certificate will be downloaded for burp. Now in newer Android devices, you can directly just open up this certificate and install it. So what you need to do first is go to files, then under downloads we have the cert.der, which is just downloaded right now. Okay, we need to rename it with something meaningful. Let's say CA certificate of burp, and we need to change the extension from DER to CER. Okay, rename. And now by going into these settings, searching for trusted credentials, and over here it lists out all the certificates which are already trusted by your Android device. So there are more than 100 such certificates which your device already trusts, and under user tab you will see the certificates which you have explicitly trusted. Currently there is no such certificate, so what we can do is we can install a new certificate by clicking on this install a certificate, then select CA certificate, then install anyway. It's ask for your for authentication, and then it will take you to your default file explorer. And over here this is the certificate which we have just renamed, right? Select it, and it says CA certificate installed. So now if we go back to the trusted credentials user tab, we see port swigger CA certificate is not trusted. Okay, cool. Now let's try to make a request to google.com. Hit enter, and now it displays up the web browser. Right now we are not getting that certificate error anymore, and under proxy tab we are getting this HTTPS request as well. Okay, cool. Clear the history. Okay, so this shows that now the basic setup is working. In this video, I am not going deep into the workings of SSL and how the handshaking is done, but just to give you some idea, during the SSL handshake, Android system verifies the server's SSL certificate with the ones which are trusted by Android operating system to ensure the identity of the server. And if the certificate is invalid or not trusted, the connection is terminated or a security exception is thrown, which we have just saw. Okay, let's now try to intercept the request for our sample application. Let me kill the previous instance of the application which is already open. And if I open this application now, it's making the HTTPS request, and we got the results as well. But under burp, we did not see any request made by this application, right? These are random requests which are coming from my device, so just ignore these. We cannot see any request being captured by burp suite. Let's see whether burp throw any error by going into the dashboard. It says client TLS negotiation failed for play.google, but not anything coming from our sample application. So it looks like burp is not able to intercept requests from our Flutter application at all. But why? That's because Flutter apps do not use devices network proxy settings, and on top of that it does not use system certificate store. So it does not matter what proxy settings we have applied in our network settings, Flutter apps will just ignore it. We need to apply proxy settings at system level, means we need to redirect all the network traffic from the device to our proxy server. To apply proxy settings at system level, there are a couple of options available for us in Android. For example, if you have root access, you can directly use IP tables command to redirect all the traffic from your mobile device to the proxy server via ADB shell. Another option is to use proxy droid application, which again requires root access to redirect all the traffic at system level. For the sake of simplicity, we will use proxy droid. It requires root privileges to apply proxies, so make sure you have a rooted device. So I have proxy droid already installed on my device, which you can see here, and when we open it, that's what we get. Under host, we need to put the IP address where the burp suite is running. The IP address of our machine is 192.168.1.18. Let's change it, 192.168.1.18. Okay. And then this is going to be the proxy port where the burp suite is listening. So as we know, it's listening on 8080 port. So let's keep it as 8080. Okay. Then make sure the proxy type is HTTP. Even for intercepting HTTPS traffic, don't make it as HTTPS. HTTP is good enough. Then if we scroll down a bit, there is another option which we need to check, that is global proxy. Make sure this is checked, and internally it also uses IP tables. So if you directly want to redirect the traffic via IP tables, you can do that. Otherwise, this application just provide a nice UI and it's easy to use. Okay, so after making the changes, all we have to do is enable this proxy switch. As you see, it got super user rights, and I think proxy droid service is now running. Now in the system tray, we see that proxy droid service is running in the background, right? Which means that all the network traffic is now being redirected to the burp suite. And to check that, let's kill the existing running application instance and launch it again and see whether burp suite is able to intercept the traffic or not. Now we see that it's trying to load the data from the server, but it's stuck here. It's not actually able to fetch all the latest news, right? And in the HTTP history, if we scroll down, these are just random requests coming from the device, but nothing coming from this particular application, which we can confirm by clearing the history. And if I launch the application again, we see that nothing has shown up here under HTTP history tab. Why is it so? Let's go to the dashboard tab under event logs. If we see, we are getting this client failed to negotiate a TLS connection to newsapi.org, right? Which is trying to connect at 443 port, which is for SSL communication. And it says remote host terminated the handshake. Okay. So if you remember initially what I told you is that if the certificate is not trusted by the client, then the connection will be terminated. And that's exactly what's happening over here at the time of SSL handshake. And because the connection is terminated, the application is not able to fetch the news and display the results. So what we can do then? To understand this, first let's see how a Flutter apps looks like when we extract the APK using APK tool. For that, let me clear out all of this. So I am currently under the directory where I have the sample application with the name app-release.apk. Okay, so this is the same application which is installed on the device. So if I run apk tool decompile app-release.apk, it will extract out all the files and directories and all the resources present inside this application. Okay, so now you see there's a new directory being created, app-release. So if we go inside it, we see all the directories and the files which is there in this application. By looking at first glance, it looks like a normal Android application. But if we go into library, we have these three different architectures. So the application is compiled for these three different architectures. Since our device is running on ARM64, so we go into this particular directory and let's list out what do we have over here. Inside here, we see we have two libraries present. One is libapp.so and another one is libflutter.so. So in any application, if you see libs directory and you find these two libraries present, this indicates that it's a Flutter based application. Now, in order to start analyzing Flutter application, we have to understand basic Flutter architecture and what these two libraries are. First things first, don't waste time analyzing the Delvik bytecode in JEDEX or any other decompiler tool because it's useless in case of Flutter application. All the app code resides under this libapp.so. So when you analyze this library, you will find that it contains a VM snapshot which Dart uses. Every piece of Dart code runs within an isolate. So in order to analyze the Dart code, we need to pass this snapshot, which is totally a different topic. And if you are interested in understanding Dart snapshots and how we can analyze the Dart code present inside this library, do let me know in the comment section and I will try to make a dedicated video on this topic. But for now, we don't have to analyze this library. Instead, we are interested in libflutter.so, which is a Flutter engine which basically provides execution environment for the Dart code present in libapp.so. And that's where the code for SSL handshake is implemented. So Dart generates and compiles its own key store using Mozilla and SS library. So to solve this, we have to dig into this libflutter.so library and figure out what we need to patch or modify in order to validate our certificate. And to give you some more context about how a Flutter application handles this, for this, Dart uses Google's boring SSL to handle everything related to SSL. And luckily, this boring SSL library is open source. So we can look into its source code to understand how it's handling the SSL handshaking and certificate verification. So if we go into our browser and search for boring SSL GitHub, we will get this repository. Right here, all the source code of this boring SSL library is present. Fortunately, we don't have to look into all the files to figure out the function responsible for handling the SSL because it's already being done by someone else, and couple of articles are already available on the internet. Okay, so basically the SSL verification process is handled inside SSL_x509.cc file, which is present inside this SSL directory. Okay, here we should have SSL underscore x509.cc. Okay, and let's have a quick look at the source code of this file. So it looks like it's a pretty huge file having a lot of functions. So all the functions are visible on this new GitHub interface. So it's easy to figure out what all functions are present. And the function we are looking for is session underscore verify. So let's filter the results, session underscore verify. There we go. So this is the function responsible for doing the SSL handshake. As you can see, its return type is Boolean, which means that if the SSL certificate is valid and trusted by the device, then it will return true, otherwise it will return false. And here it's taking 3 arguments. And here we clearly see that it's returning false in case any SSL verification fails, right? And in the end, if SSL verification is successful, then it's returning true. So now all we have to do is to figure out this function in libflutter.so library and manipulates its return value to always return true. But since we have a release build and all the symbols are stripped, how can we search for this function? First of all, let's open libflutter.so in Ghidra disassembler. You can obviously use any other disassembler of your choice. So I have Ghidra already opened here. First of all, let's import the library, which is libflutter.so. Okay, give it some time to import the file. Okay, and once it's done, we can simply double click it to start analyzing this library. libflutter.so has not been analyzed. Would you like to analyze it now? Yes. Leave all the checks by default. No need to make any modifications. Simply click on analyze. Let's wait for some time as it's a pretty huge library and Ghidra will take some time to disassemble and analyze it. Alright, so the analysis is done now. It took almost 10 to 15 minutes for me, depending on the processing speed, it might be less. Now, as you see, since it's a release build, there are no symbol names available, right? So let's see now how to identify that SSL verify function. So if we go back to the source code where we have this session verify cert chain function available, if we see over here, under this if condition, that's where it's actually trying to verify whether the SSL certificate which came from the server is trusted by the Flutter application or not. And if not, then it's returning false. But before returning, it's throwing an error via OpenSSL put error macro, right? So the best way to figure out this function in the disassembly is to look for this macro, which is present at line 394 for this version of boring SSL, which is present on the GitHub. If you are trying to do it for some other version, then you might get a different line number for OpenSSL put error macro. Okay, so if we go back to Ghidra disassembly and search for scalars under specific scalar, if we put 394, which is the line number where OpenSSL error macro is being called, and do a quick search, we got couple of results, right? But there is only one result having move instruction where it's trying to put this 394 line number. Hex 18A is equivalent to 394 in decimal. So that's where it's trying to put this line number in W3 register, right? And it's coming from function 6DC730. Okay. So when you click on this, it will be automatically synced in your decompiler and the disassembly view. So as you can see in the decompiler, we are now inside this DC730 function, which is present at this offset. Okay, so this function should be the one we are looking for. Let's make sure it is by looking at the number of arguments the function is taking. So here it's taking 3 arguments, right? Let me expand this window a little bit. So yeah, here it's taking 3 arguments and Ghidra automatically identified the data type of the argument. So the first one, it identified it as long and other 2 are long pointers. Okay, note that these identified data types might not be correct always because it predicts based on some heuristics. And if we look into the source code of this function, it's also taking 3 arguments and all these 3 arguments are of pointer type. So there are chances that Ghidra misidentified this argument as long. Okay, but the point being it's taking 3 arguments, which is similar to what our original function is taking, right? Next, let's see the first line in this decompile code where it is trying to store hex 50 in this pointer variable. If we look the same in the source code, we have SSL add internal error, which is a constant value, and it's also being stored into a pointer variable, right? So far this looks similar. And also to make sure that this value, this constant value is hex 50, what we can do is we can search for this constant. If we just Google the constant name for value, we will get the first result, which says ssl.header file. And over here, if we look for this constant, there we go, it's defined as TLS add internal errors. What's the value of this? If we click on it, TLS add internal error is assigned as 80. And hex 50 is nothing but 80 in decimal. Okay. Then next, after this, we have a if statement, and in the source code as well, after this we have a if statement which looks somewhat similar to the one which is recompiled over here. It's comparing this value with null, and this is what happening over here. This value is being compared with null in this if statement, right? Then finally, just to be 100% sure, let's look for some hard-coded strings. So if we look in the source code, here we see that there are some hard-coded strings like SSL underscore client and SSL underscore server used inside this function. So we should have these strings somewhere inside this function. And if we scroll down a bit, here we can see SSL server and SSL client. Cool. So we do have these strings in the decompile function, which we have identified. So at this point, we can be sure that this is the routine which we are looking for, and it has so many similarities with the source code of the function. So we can be sure at this point. For better understanding purpose, let's rename this function with session. Was the name session verify cert chain. Verify cert chain. Okay. Cool. So as already explained, now we need to modify the return value of this function to always return true. This can be done statically also by patching the library and then resigning the APK. You can try it yourself, but for now we are going to use a dynamic approach where we will use Frida framework to hook this function in order to manipulate its return value. Okay. So let's open up Visual Studio. Yes, I trust the authors. And inside this, we can create a new file. I'm going to name it as sslbypass.js, or to be sure, Flutter sslbypass.js. Okay. Inside this, first of all, we need to identify the base address of libflutter.so. Once we have the base address, then we can attach the hook to that particular offset or the function. And the best way to do this is to identify the base address of the library at the time when it is being loaded by the loader of the operating system. For that, we are going to hook linker64 because linker is responsible to link all the dependencies required by the loading library when it is being loaded. We are basically interested in two functions from linker62. First one is do_dlopen function, which is nothing but a wrapper on top of dlopen function, which actually used to load the library in the memory at runtime. And the other function is call_construction, which get called first before even calling the actual constructor of the library. So to do that, we can use process.findModule by name API of Frida to find out where the linker64 module is, and then we can enumerate all the symbols using enumerate symbols method. Now instead of storing it into a variable, we can directly apply for each loop to go over each symbol one by one. Okay, so the syntax for each loop looks something like this. Here, let's name it as symbol, then the body of the loop. Now we need to extract those two functions, right? So we can compare the name of the symbol with the one we are interested in, which is do_dlopen. And the other one we are looking for is symbol.name.index of call_constructor. If it is greater than equal to 0, then we are sure that the symbol is do_dlopen and call_constructor. Let's save the addresses of these function in their respective variable. So I am making do_dlopen variable, initialized it with null initially. Similarly, for call_constructor, I am going to make this variable and initializing it with null. Then we need to initialize the address using symbol.address. Similarly, for call_constructor, we can get the address of the symbol using this. Okay, cool. So now we have the addresses of these two functions from linker62. Okay. Next, we need to attach the hooks on these two functions one by one. So we can use interceptor.attach API of Frida for this purpose, where it takes address where you want to attach the hook. So we want to attach hook on do_dlopen and then the function body. Inside this, we can extract the name of the library which is being loaded by the linker. So let's extract that library name inside library path variable, this .context.x0. So as per ARM calling convention, the first argument of a function is always stored in x0 register. So that's why we are using x0 register to read the value. Okay, since we are only looking for libflutter.so, that's why we need to filter out the library path. So if library path is having libflutter.so, then only we are going to attach further hooks. Now after do_dlopen function, call_construction method will be called. Okay, so we can attach the hook interceptor.attach to call constructor function, and then it will take function, and inside this we can get the libflutter module object via process.findModule by name. This will take again libflutter.so as argument, and let's save this object in a variable module. Okay, And let's put a print statement to see whether our script is able to find out the base address of this libflutter.so properly or not. Libflutter is loaded at, then the base address we can get from this module object via module.base. Okay, cool. Let's save the script. Let's check whether the script is able to extract the base address of libflutter.so or not. But before running the script, we need to make sure that our Frida server is running. So what I'm going to do is I'm going into the ADB shell, taking root permission, going into data local temp because that's where my Frida server is present, and then run Frida server. Now Frida server is running on my device, and now we can run this script. But in order to run it, first we need to know the package name of our application, which we can get using Frida ps-uai. So this will list out all the installed application, and the package name of our sample application is com.fatalsec.ssl_pinning. Let's copy it, clear the console, and now using Frida-u to tell Frida that our device is connected via USB, then -l to list our Frida script, which is flutter_ssl bypass.js, and then -f to forcefully spawn a new instance of the application followed by the package name. Enter. Processing instruction is not defined. Okay, this is only process, not processing instruction. Exit. Clear. Let me bring our device on the top, and if we launch the script, we are getting that libflutter is loaded at this base address, but as you can see, it's getting loaded multiple times, which actually we don't want. So we can make use of a flag variable library loaded, initialize it with 0, and here we can compare if library loaded is equal to 1, is equal to 0. And inside this, once it is loaded, initialize it with 1 so that it will be loaded only once. Clear the console, run the script again, and now we are getting libflutter is loaded at this base address only once. Now to attach the hook to the SSL verify cert function, let's create a function inside this and name it as, what was the name, session verify cert chain. Let's copy it, paste it. Okay, and here we will take the address where we want to attach the hook. And as you know, using interceptor.attach API of Frida, we can attach the hook on this address. Then here it will take body with 2 attributes on enter, which will get called when the function is called initially, and then on leave, this will be triggered when the function is about to return. Okay, let's put some logs to see the current status, what we are getting. So this session verify cert chain return value is this. Now let's call this function inside our call constructor hook, where we have identified the base address. Right here we need to pass the address where we want to attach the hook, which is going to be the offset of the function where certificate verification is being done. If we go back to Ghidra, we see that this function is present at this offset, right? But this offset is not the real offset, because in Ghidra, the image base address starts from 1 lakh or something, right? Which we can see by opening the memory map. And if you click on this home icon, you will see that the base image address is starting from this. So in order to correctly calculate the address at runtime, what we have to do is we need to subtract that value from this offset, and then we will get the real offset. So let's copy this, open the calculator, paste it, and subtract that value. And now we got 5DC730. So this is the offset where this function is present. And as you already know that at runtime, we need to calculate the actual address of that function when it is loaded in the memory, which we can do by using the base address and adding this offset to the base address, right? This is actually 5DC730. Okay, save the script. Let me bring our device back on top of the screen. And if we launch the script again in the console, we see now that session verify cert chain function is called with the return value 0, which means this function is returning false as of now, right? And that's why the connection is getting terminated, because the verification is failed. So to bypass this check, what we can do is simply we can modify this return value using the replace function inside on leave, and to make it true we can replace it with 1. Let's save the script, exit it, clear the console, and launch the script again. This time we see that the return value is modified to 1, and in the app also we can see that it's now able to fetch the records, which means that the connection is not terminated and the SSL certificate is trusted by the Flutter application. So we should be able to see the request in the burp suite. So if we go back to the proxy tab, over here we see that we are getting this request newsapi.org, right? And here in the request we see the request payload, and in the response, we see in the form of a JSON, and this is the news which is being displayed in the UI, right? Okay, cool. So now we are able to intercept the request. And just to explain you again why we have enabled use invisible proxy feature is because in Flutter, the HTTPS requests are non-proxy style requests by default. So in the request payload, you see that it's just calling the API without the host name. So that's why we have to enable that feature. Otherwise, even after bypassing the SSL verification check, you will not be able to see the request. Once this function is identified and hooked and the return value is modified, it does not matter whether the application is using a custom certificate, which is usually the case with SSL pinning because we have bypassed the whole certificate chain verification process. So that's it, and I highly appreciate your feedback. So if you have anything to suggest or any comments on how I can improve, then please do let me know in the comments. And if this video receives a significant number of views and likes, I will plan to create a follow-up video on this where we will explore automating the SSL verification bypass process. So instead of manually hunting for the function offsets, we will develop a script that can discover these functions, making it applicable for all Flutter apps. So if you found this video helpful, please show your support by hitting the like button and sharing it with your friends. Don't forget to subscribe to the channel because we regularly release new videos and your support keeps us motivated. Thank you, and I will see you again in the next video very soon.